Public Exam Review, Unit 5, Chapter 5, Trigonometric Functions and Graphs. In this presentation, we will look at the applications of the sine and cosine functions. Here we will focus on solving problems graphically that can be modeled using sinusoidal functions. In the first example, we have a wheel of radius 30 centimeters, has a center 36 centimeters above the ground. It rotates once every 12 seconds. Determine an equation for the height h above the ground of a point on the wheel at time t seconds if this point has a minimum height at t equals 0 seconds. To begin to come up with the solution for this equation, we recognize that the center of the wheel has its center 36 centimeters above the ground. That gives us the equation for the sinusoidal axis. So if I were to sketch a graph to resemble this situation, it would be as follows. The center of the wheel is 36 centimeters above the ground. So that gives us the equation for the sinusoidal axis that will pass through that point. That will be through y equals 36. The next thing we need to notice is that the wheel has a radius of 30 centimeters. The radius of the wheel is 30 centimeters. And we are also told that the minimum height occurs at t equals 0 seconds. So if the horizontal axis here represents the time t, and that time is in seconds, the vertical axis represents the height, and that height is in centimeters. So we know that when t is equal to 0 seconds, that the minimum point of that wheel, if the radius is 30 centimeters, then the minimum point has to be at a height of 6 centimeters. And the maximum height would have to be 36 plus 30, which is at a height of 66 centimeters. So we know here from the equation that there's a maximum value. The maximum value can be found by taking the center line at 36 and adding the radius of the wheel. So the maximum height would be at 66 centimeters, and the minimum value of this function will be at 36 minus the radius of 30, which is at 6 centimeters. Once you have the minimum and the maximum values of the function, you can determine the equation of your sinusoidal axis. The sinusoidal axis is equal to the maximum value of the function plus the minimum value of the function divided by 2. So we have 66 plus 6 divided by 2, which is equal to 72 divided by 2, which is equal to 36. So that will give us the value of d in the equation. D will equal 36. As a result of that, that eliminates A and B as possible multiple choice items. We are told that the minimum height of this function begins at t equals 0 seconds. So the first point on this graph will occur at 0, 6. We are also told, and this is a very important piece of information, that the wheel rotates once every 12 seconds. So if it begins at 0, 6, then by the time it gets back to 6 again, it will be at 12 seconds. So that will be another minimum point of the function, which occurs at 12 and 6. Halfway between 0 and 12, you should reach a maximum point on the function, which will occur at 6 seconds. So you will have the point 6 and 66 as your new point maximum value of the function. Halfway between 0 and 6 at 3 seconds, the radius of the height of the wheel will be at 36, and at 9 seconds, the height will be at 0 seconds. So this represents one full cycle of the cosine function. Now, using that section of the graph, you can now determine the amplitude of the function as well as any horizontal or vertical translations, as well as any reflections that may exist. So now we will look at, first of all, you can see that the graph, there has been a vertical reflection in the x-axis. So that tells us then that the value of A is less than 0, because normally the graph would open as an upward V, but this is an upside down V. So we know that the leading coefficient, the value of A, has to be less than 0. The amplitude of the function can be determined by taking the maximum value and subtracting the minimum value divided by 2. So we have 66 minus 6 divided by 2. 60 divided by 2, we have an amplitude equal to 30. So that tells us then that the value of A is equal to a negative 30, since A has to be less than 0. Notice that the normal cosine graph will pass through the point 0, 1. So that means, because the beginning point here on this graph is that still occurs when t is equal to 0. Therefore, there is no horizontal translation for this function. However, the period of the function, and this is very important, the period for which the length for which one full cycle occurs is going to be equal to 12 seconds. So that enables us to determine the value of the horizontal stretch, where the period is equal to the horizontal stretch multiplied by 2 pi in this case. So we have 12 divided by 2 pi is going to equal the horizontal stretch. 12 over 2 pi simplifies to be 6 over pi is equal to the horizontal stretch. Therefore, the value of b in your equation will be the reciprocal of that, which is pi over 6. So now, if you are looking for the equation of in terms of cosine, it will be given by a times the cosine of b times x minus c plus d. The value of a is negative because of the vertical reflection in the x-axis. The amplitude is equal to 30, multiplied by the cosine of the value of b is equal to pi over 6, because the horizontal stretch was 6 over pi, and that will be multiplied by x minus 0, since there is no horizontal translation or no phase shift, and we will add 36 at the end, since the center line is 36 centimeters above the ground. So y represents the height of the function. H is equal to a negative 30 times the cosine of pi over 6 t plus 36. And this answer corresponds to D as a multiple choice answer. In example 2, a mechanic rolls a wheel of radius 42 centimeters, and the wheel it rolls makes 1 revolution every 2 seconds. The diagram below illustrates the vertical motion of a point on the wheel over time. Find an equation of the function shown as a transformation of sine or cosine, and we have to show all workings. So the first thing that I would notice here is that the radius of the wheel has a radius of 42 centimeters, and it makes 1 full revolution every 2 seconds. So to illustrate that in the diagram, we have 1 full revolution. If we begin here at t equals 0, then by the time it gets back to this position again, that time would have to be 2 seconds. If it makes 1 full revolution, and this would represent 1 full revolution of that wheel every 2 seconds. So because the radius of the wheel, which is the distance between the center and a point on the circumference of the circle, the radius is equal to 42 centimeters. So we know that the horizontal central line that passes through this graph passes through y equals 42 in this example. So the equation of the sinusoidal axis is y equals 42, and that will give us the value of d in our equation. The maximum height reached by that wheel has to be 42 plus 42, which represents the diameter of the wheel. So the maximum height will occur at 84, and the minimum height will occur at 0 because the wheel is rolling along the ground. So then at 1 second, the center of the wheel is at 42, and then at 0.5 seconds, we have the 0.5 and 0, and 1.5 and 84 represents a maximum point on that graph. So using that cycle of the function, we can now determine the equation. So algebraically, we can determine that the equation of the sinusoidal axis is equal to the maximum plus the minimum. We already know what the answer is going to be, divided by 2. The maximum value of the function is at 84, which represents the diameter of the wheel, plus a minimum value, which is at 0, divided by 2. 84 divided by 2 is 42 centimeters. So we have the sinusoidal axis is at y equals 42, and that gives us a value of d in the equation of the function. Similarly, we can determine the amplitude of the function by using the maximum value minus the minimum value divided by 2. So we have 84 minus 0 divided by 2, which is equal to 42. So the distance then, the distance between the sinusoidal axis and a maximum or a minimum point on the function is equal to 42. The amplitude gives us the value of a in the function. A is equal to 42. However, in discussing the value of a, notice that we have kind of a sideways S-shaped graph highlighted in the diagram. So we are going to use the function for sine in this case. And because it's opening downward as opposed to going upward, we know that there's been a vertical reflection in the x-axis for the base graph of sine x. Before I go into each of the equations, the period of this function, the period for which one full cycle occurs, is equal to 2 seconds. That enables us to determine the horizontal stretch. We can use the formula where the period is equal to the horizontal stretch multiplied by 2 pi. In this case, we'll use radian measure in our answers. So the period is equal to 2 equals the horizontal stretch multiplied by 2 pi. Dividing both sides by 2 pi, we have 1 over pi is equal to the horizontal stretch. Therefore, the value of b in our equation will be the reciprocal of that, which is equal to pi. Now we can determine the equation in terms of sine or cosine. So the first one we'll do is we'll determine the equation of the function as a transformation of y equals the sine of x. So we will put our equation in this form. Y equals a times the sine of, that would be b outside of x minus c plus d. In the case of the sine function, it begins at, the normal sine function begins when p is equal to 0, and such is the case in this example as well. So we know here that the value of a is going to be less than 0 because there's been a vertical reflection in the x-axis. And the amplitude of the function is equal to 42. Therefore, the value of a here will equal a negative 42. The value of b we've already determined to equal pi. The value of c, I want you to notice here that there has been no horizontal translation. Therefore, the value of C is just equal to 0. And we've already determined the value of D to equal 42. So one possible equation to represent this situation is y equals a negative 42 times the sine of B, which is pi, times x. C is 0, so we don't need to worry about that, plus 42. And that will give us one equation that represents this situation. If we were to develop an equation in terms of cosine, much of the same information can already be used. But we need to select a region of the graph that represents a V-shaped function. So I'm going to take this maximum point here of this graph, and I can use the upside down V if you'd like. So I can go from 0.5 up to this point here, which would be at 2.5. So this region of the graph would represent the cosine function. Notice that it's an upside down V. So in this case, we would have a transformation of A times the cosine of B times x minus C plus D. Again, you can see that there has been a vertical reflection in the x-axis because our V is opening upside down. So that means that the value of A has to be less than 0 again. The amplitude is still equal to 42. So that tells us that the value of A has to equal a negative 42. In this case, though, notice that the initial point on the graph begins when the time is equal to 0.5 seconds. So that indicates to us that there has been a horizontal translation equal to 0.5 seconds to the right. So that tells us that the value of C will equal 0.5. We can now determine the equation using the other pieces of information as follows. Y equals a negative 42 times the cosine of B is still going to be pi times x minus decimal 5. And then we add 42 at the end. The number of solutions for this question will vary depending upon the region of the graph that you choose in order to get your graph. But these would be two possible equations, one in terms of sine and the other in terms of cosine that you can use. In example 3, a mother watches her child on a merry-go-round. The child is at a minimum distance of 3 meters from his mother at the start, and 6 seconds later is at the maximum distance of 15 meters. What is the equation of the sinusoidal function that models this situation as a transformation of the sine of x? As I look at this question, I determine that the maximum value of the function, the maximum value occurs at 15 meters. And the minimum value of the function is at 3 meters. I should highlight that in the question itself. So we are told that it's a maximum distance of 15 meters, and we're told that the child is a minimum distance of 3 meters from his mother at the start. So if you know what the maximum and the minimum values of the function are, that will enable you to determine the equation of the sinusoidal axis as well as the amplitude of the function. So let's begin by doing that. The sinusoidal axis is equal to the maximum plus the minimum value divided by 2. So we have 15 plus 3 divided by 2. 18 divided by 2 is equal to 9. That gives us the value of D in the equation. The amplitude can be determined using maximum minus the minimum value divided by 2. So we have 15 minus 3, which is 12, divided by 2 is equal to 6. So we need to sketch a little graph of what's happening here. So in the graph, we are, or in the situation, we are also told that the child is at a minimum distance of 3 meters from his mother at the start. So at the start would be when t is equal to 0. So when t is equal to 0, the child is 3 meters from his mother. And then it says 6 seconds later, he's at a maximum distance of 15 meters. So the maximum distance will be occurring at 6 seconds later. So if it takes from 0 to 6 seconds to reach a maximum value, it will take another 6 seconds to get back to a distance of 3 meters again. Okay, so that's how you represent the situation. Halfway represents the equation of the sinusoidal axis. So let me put that in. The sinusoidal axis will occur. I'll put that in blue here. So this value is at 9. So the equation of that sinusoidal axis is through y equals 9, which is halfway between 3 and 15. So then you can come up with another couple of points on your graph of this function. At 3 seconds, you will have the y value to be at 9, and at 9 seconds, it will also be at 9. So this represents one full cycle for this function. In this case here, we have an upside down v, whereas the situation asked us to write the equation of the sinusoidal function as a transformation of the sine of x. So I would like to extend this graph so that we get the sideways S-shaped function. So every 3 seconds, so at 15 seconds, the y value will be equal to 9. So we're just extending that, and I'm going to highlight the region of the graph that I would like to discuss. Because I'm looking for the graph of sine, I'm looking for this S-shaped section of the graph. So that's what I will focus on there as we discuss the other parameters for this function. So note that the sinusoidal function here is going upward to begin with. So that tells us that there are no vertical reflections. There are no vertical reflections. Therefore, the value of A must be positive. It will be greater than 0. And because the amplitude is equal to 6, we know that the value of A will actually equal 6. As well here, in terms of talking about the stretch factors, you have an amplitude equal to 6. The distance between the sinusoidal axis and the maximum or minimum values of the function is equal to 6 units. So we have the value of A. The other thing we need to look at there is the period of the function. We are told that the one full cycle will occur between 3 and 15 seconds. So that distance then between 3 and 15 gives us the period of the function here, which is equal to 12. That period will enable us to determine the horizontal stretch factor. So the period is equal to the horizontal stretch. We can use degrees or radians here, so why don't we use degrees this time? It will be the horizontal stretch multiplied by 360. So you have 12 is equal to the horizontal stretch multiplied by 360, dividing both sides by 360, so that reduces to be 1 over 30 is equal to the horizontal stretch. That gives us the value of b in our equation to be the reciprocal of 1 over 30, which is 30. As well, the sine function normally begins at t equals 0, but here it's beginning when t is equal to 3. So that tells us that there is a horizontal translation equal to 3 units to the right. Therefore, the value of c is equal to 3. Now that we know the values of a, b, c, and d, we can now come up with the equation of this function, y equals a times the sine of b times x minus c plus d. So we have y equals 6 multiplied by the sine of 30 times x minus 3 plus 9. And that's one possible equation for this function in terms of sine. In example 4, we have a swing is located directly in front of a tree. As Danielle swings, she is 7.3 meters away from the tree at the furthest point of her swing, and 3.5 meters away from the tree at its closest point. She is at a maximum distance away at time t equals 2 seconds, and the next maximum at time equals 2.8 seconds. Determine a sinusoidal model for this in terms of both sine and cosine. And this time we are asked to use radian measure. Some key points on this function. We are told that as she swings, she is 7.3 meters away at the furthest point of her swing, and 3.5 meters away from the closest point. So that enables us to determine the maximum value of the function. The maximum value here is equal to 7.3 meters, and the minimum value of the function is at 3.5 meters. Once you know the maximum and the minimum values of the function, you can now determine the equations of the sinusoidal axis as well as the amplitude. So the sinusoidal axis will equal the maximum plus the minimum value divided by 2. So we have 7.3 plus 3.5, which is 10.8, divided by 2 is equal to 5.4. So the equation of your sinusoidal axis is y equals 5.4, and the parameter d is equal to 5.4. Next, we can determine the amplitude in a similar way by taking the maximum value minus the minimum value divided by 2. So we have 7.3 minus 3.5 divided by 2, which is equal to 1.9. So that gives us the value of A. A is equal to 1.9. Now, we are told we need to sketch a graph now to determine the period and any translations that may occur. So just to sketch a graph of what's happening here, we don't need to worry about the negative time, nor do we need to worry about the negative height. So we are told here that she is a maximum distance away at time t equals 2 seconds. And then the next maximum time, I should highlight that for you. The next maximum time at t equals 2, and the next maximum is at 2.8. So I'm going to use a scale of 0.2 on this graph to represent this situation. So I will go up in increments of 0.2. Oops, sorry about that. So we have 0.2, 0.4, 0.6, 0.8, and 1, 1.2, 1.4, 1.6, 1.8, and 2. And at 2 seconds, she is at a maximum distance. So that maximum distance was at 7.3. So just to record that point. And then this would be 2.2, 2.4, 2.6, and at 2.8, she is at the next maximum time again. This is 2.8. So halfway between 2 and 2.8 is 2.4. Halfway between 2 and 2.8 is 2.4, and that's when she will be at a minimum distance. And the minimum distance in this case was equal to 3.5. We'll just estimate where that's at. And you know that the sinusoidal axis will pass halfway through there at 5.4. So let me draw in the sinusoidal axis. I think that's a necessary starting point when trying to determine the equations of these functions. So then at 2.2, you will be at 5.4, and 2.6, you'll be at 5.4. So this represents one cycle of this transformed function. Okay, so now using that, we could come up with the equation of the function in terms of cosine right away, because we have the V-shaped graph. In the meantime, before we do that, let's look at the period of the function. The distance between 2 and 2.8 tells us that the period of this function is equal to 0.8 seconds. The period is equal to the horizontal stretch multiplied by 2 pi, in this case because we were told to use radian measure. So 0.8 is equal to the horizontal stretch multiplied by 2 pi. You divide both sides by 2 pi, and you will have the horizontal stretch is equal to 0.8 can be written as 8 over 10. Divided by 2 pi is the same as multiplying by the reciprocal, 1 over 2 pi, and that is equal to 8 over 20 pi, which reduces to be 2 over 5 pi. If that's the horizontal stretch, then the value of b in your equation will be the reciprocal of that, which is 5 pi over 2. Now we can determine the equation in terms of cosine. So we have y equals a times the cosine of b outside of x minus c plus d. Notice that there are no vertical reflections this time because your graph is the V-shaped graph is drawn properly. So we have the value of a here to be 1.9 times the cosine of b is going to be 5 pi over 2 times x minus. Now, this time, notice that your graph here is starting at t equals 2 seconds. So we do have a horizontal translation here equal to 2 units to the right. So that gives us the value of c to equal 2 in our equation. And the value of d is 5.4. So this is one equation that represents this situation in terms of cosine. Now, we need to get the sideways S-shaped graph, so I'm going to extend this graph more to the left, and I'll just change the color there so that we can see that. So between 2 and 2.2, so between 1.8, at 1.8, you will have another point on this graph at 5.4. So if I highlight this section of the graph, you now have a sideways S shape that you can work with to determine the equation in terms of a sine function. So let's look at that in terms of y equals a times the sine of b outside of x minus c plus d. In this case, again, your There are no vertical reflections because your graph is going upward from the start. So we have the value of A will be a positive 1.9 times the sine of, the value of B is 5 pi over 2, and this time we have a horizontal translation. The graph in this case is starting at t equals 1.8. So that tells us that there's a horizontal translation equal to 1.8 units to the right, which also gives us the value of C to equal 1.8. So we have x minus 1.8 and then plus D, which is 5.4. So this gives us another equation of the same function in terms of sine. So now you have two equations here that you could use. And again, answers will vary depending on which section of the graph you choose to come up with your answer. What I recommend in solving any of these word problems or converting an application type of a question in terms of an equation is to begin by determining the maximum and minimum values of the function. Then you can use the formula to find the equation of the sinusoidal axis. The sinusoidal axis is determined by the maximum value plus the minimum value divided by 2. And this value for the sinusoidal axis will give you the value of D in your equation. Then you can use the formula to determine the amplitude of the function. Remember that the amplitude is equal to the absolute value of A. It is found by taking the maximum value of the function minus the minimum value divided by 2. Then you need to select a region of the graph to represent one cycle of either the cosine function or the sine function. If you're looking for one cycle of the cosine function, look for the V-shaped graph. Okay, either the V-shaped graph is opening upward, or if you have a reflection, there will be the V-shaped graph will open downward. In the case of the sine function, look for the sideways S. Or if it opens downward where there's been a vertical reflection, you still look for the sideways S. And that will be the section of the graph that represents one cycle. Once you've got one cycle of the graph, that will enable you to determine the period of the function. If you know the period of the function, you can then determine the horizontal stretch of the function. Determine if any vertical reflections exist. That would be if there's a vertical reflection in the x-axis, then you will have the value of A would have to be negative. And if any horizontal translations exist, that will give us the value of C. Thank you for your time and your attention. If you have any questions in particular that you would like addressed, please pose your question in the question forum, and we will be happy to answer it for you. Thank you.